Alright. Doing some of the final touches. I got the fan that's going to be cool in the heatsink on the SSRs rolling. SSRs are plugged in also, working alongside the actual relays. And everything's working from what I've had so far, and I'm testing from going into the circuit, through the relays, the AC path. And I tested this one, it worked out. I figured I'd show up for this one. Okay, we got it off, and the multimeter is reading overload. There we go. We got a path. So each one of these, when they're on and off, actually has a pretty good path, and I'm going to set up an experiment so I can show why these are here. And it's kind of about speed, because these are in the milliseconds and these are far under that, really. So give me just a second, I'll set it up. So here's the test. We got a trigger point. We got to set up 13 volts. We're going to push forward until our indicator light turns on. That means we're above the reference, and when I hit start, we'll go into the green mode, which means we're going. And now we'll set the singles right here, and when I hold down, alright, there we are, and about 615 microseconds. It's not too shabby. It's a lot faster than these, which are up in the milliseconds. Even when you're going from making it be close to letting it open, where the spring's involved, it's still got a couple milliseconds. So this is quite a bit faster, but the reasoning behind the two of them having physical relays and solid state relays is because this one would fail, most likely closed, and it would be a short circuit. And this one would fail, most likely closed, and be a short circuit. But both of them probably are not going to fail. So the thinking behind it is redundancy, kind of like with an airplane. So if there's two systems trying to do the same thing, then you have a lot likelier chance of that one time when something goes really bad, actually making it through it. So what else I've been busy with is I've been busy with the box I'm going to keep it in. Everything's going to be fastened down, that way I can use the nifty handle on the side of the box to make it portable. I have one of the computer cord plugs, so it's kind of like the cord comes out, can be folded up and put inside of it, which is kind of nice. I like it. I think that'll make it quite a bit nicer. And then I have the programmable breaker relay, and then I have an RCD and a GFCI. A little bit light from when I started, and this is right here is an outlet that is bypassing both of those for the controls that go to the actual amperage limiting circuits. That way whenever the over amperage occurs, that control will stay on. If you look at this, I got a switch all the way up here, far away from everything. Turn it on, and this guy comes on. I have a light bulb plugged into it, so it might get bright, but there we go. And there's the readout. Tells you what it's pulling, and you can change that. There's settings. Goes for over voltage, under voltage, and has thresholds and over amperage. Now the GFCI and the RCD, those go without saying, just being something smart to plug broken things into. I'd rather have those pop than my tools. Once I get this together, I think it's going to come out to be pretty nice.